This lecture we're going to focus on plant growth regulators. These are chemicals that are often used in turf management today, both in um, a more managed situation like a golf course, but also on other higher cut turf areas, even home lawns. So these kind of broadly defined, these plant growth regulators are chemicals that alter the growth rate of the turf. So they affect any number of plant growth processes, biosynthesis pathways, and so forth. So the reason that they're used primarily is just to reduce mowing frequency. They have the effect oftentimes of reducing vertical growth rate. So that can obviously reduce mowing frequency. So that results in a time savings, a money savings, a reduction in clippings. And this reduction in clippings can have beneficial effects in terms of removal of compost off-site into landfills and so forth. They can also be used to reduce seed head production. So, for instance, with annual bluegrass, very prolific seed head producer, there are some of these compounds that can be used to reduce the formation of those seed heads if applied properly. When these are used to reduce vertical growth rate, those resources that the plant has, the energy that the plant has produced, can then be diverted to lateral growth and root development. So you end up with very much a healthy turf stand. And a lot of times they're used in situations where the aesthetics or playability are an issue. So to make turf look a little better, a little more consistent, a little more uniform, and also to help with playability issues. So the first plant growth regulators for turf were really used about 40, 50 years ago, primarily in the south on roadside grasses, for instance, Bahia grass, some tall fescue, where these grasses were growing vigorously along roadsides. Local governments were spending a lot of time and money to mow them down. So these products could be sprayed, and there could be huge savings in the amount of mowing that was done on roadsides in the south. There were several problems with these early chemicals. One, they just were a little more phytotoxic, so they caused discoloration. There was thinning, which led to increased weed pressure. Rooting was reduced, more disease due to weakness of plants. Differential suppression is a problem even now with the newer products, but especially then, it was some of the species that were along roadsides were more affected than others, so you get mixed results. And recuperability of grasses then during stress periods was poor because of all these other problems. So the newer products that have been used in the last couple decades are much reduced in their phytotoxic effects on the plant. They are often used for species conversion, where they kind of take advantage of that differential suppression in a mixed stand. And they're used commonly for seed head suppression. They generally do not negatively affect any lateral or horizontal spread. In fact, they usually help out in that area. And the big thing is clippings reduction. You can reduce the mowings by several times over the growing season. Color is often improved because there's now more chlorophyll per area. It's the energy the plant seems to compensate for lack of leaf area, surface area, with the production of more chlorophyll. And they often have better shade performance. So in a shade situation, you often get elongation of the leaf as it looks for light, and this is often reduced because some of the modes of action of these plant growth regulators have to do with reducing cell elongation. So the plant hormones, this is a list of the main 5 groups, and you've seen these and dealt with these in other courses. The bottom 3, they're ethylene, cytokinins, and gibberellins. Those are the ones that are somewhat associated with these plant growth regulators that we will discuss, especially the gibberellins. So we'll concentrate. Most of the products that we're going to talk about really do impact the gibberellins. So it gets a little confusing in how these products are classified. They used to be classified as either type 1 or type 2. And now they're classified according to a letter scheme by some people. So we'll use both. These are things you could run into both classifications. So we'll do both. The type 1, type 2 system, type 1, these were products that were absorbed foliarly, so they were absorbed by the leaf. And this is an advantage because you don't have to worry about getting the chemical down into the soil so that the root can take it up. So foliar absorption is a positive. These inhibit cell division in the meristem region, so they really are interfering with cytokinins, and which leads to more phytotoxic effects than the gibberellin inhibitors. The effect is quite rapid duration. These can usually be effective for about 3 to 4 weeks after application. And if you think about it, most turf herbicides obviously affect plant growth, and herbicides can be included, some herbicides can be included in this category because when used at low rates, they can have a plant growth regulating effect. So the other group then, according to this classification, would be type 2. These would be the gibberellin, or sometimes referred to as GA, gibberellic acid inhibitors. These are typically crown or root absorbed, which would not be an advantage because it's easier to get them into the plant if you can just spray them on the foliage. They suppress components of the gibberellin's biosynthesis pathway. They result in, the net result is a reduction in cell elongation. And the duration would be a little longer than the type 1, and these are certainly less phytotoxic than the type 1 materials. Okay, now we'll go into the newer classification scheme, and this is a little more helpful in terms of classification because it kind of breaks down these compounds into more useful categories. So the Class A classification, these products would inhibit GA synthesis late in the biosynthesis pathway, and I'll show you what I mean by that in a little bit. So later on in the pathway, the plant cells end up not elongating as much. You get shortened internodes, you get overall reduction in plant growth, especially vertical growth rate. These, however, so I just mentioned with the type 2, if we go back a slide, I mentioned that most of these type 2s are crown or root absorbed. However, these Class A compounds are absorbed by foliage, so that's another nice advantage. The member of this group that we would know is trinexapac ethyl, primo, commonly used in turf situations. A lot of data showing improved density, reduced clippings, improved color, slower growth in shade, better quality in shade. Overseeding use where you slow down the grasses that are for conversion from warm season grasses to cool season grasses in the winter in the south. Application of these products to slow down the warm season grass while that cool season grass is germinating. They can result in some seed head reduction in POA stands, but not, it's not the primary use. And we often see a rebound effect with this compound. So what I mean by rebound effect is if you spray this compound on a turf, and you get regulation, so you get reduced growth. After a certain number of weeks, kind of depends on the environment and things like that, you'll actually get a surge of growth that exceeds what a typical growth pattern would be for that species. And it has something to do with the fact that there's kind of this pent-up energy, carbohydrates in the plant, and so once regulation stops, there's a lot of growth. So timing of the applications is important because you want to make sure you re-regulate the plant then ahead of that rebound time. So Class B would be very similar in terms of their mode of action. The problem with this group would be that it inhibits the GA synthesis pathway earlier than Class A. So because it's earlier, it affects more gibberellins. There's a number of gibberellins, and they all are made somewhere in the gibberellin pathway. And I'll show you in a little bit where in the pathway the regulation occurs determines how many gibberellins you affect. So really, there might be just a couple gibberellins that affect cell elongation. So a good chemical, a safe chemical, would only affect a couple gibberellins by targeting some component of the pathway late in the pathway. Because this type of compound, this Class B, affects gibberellin acid GA synthesis early in the pathway, there's many more gibberellins affected and other plant components affected, so there can be a greater risk for phytotoxic effects. This is a root-absorbed compound. Here's some examples for primidol, also trade name Cutlass. and then paclobutrazol, very commonly used for slowing the growth of POA when you have both creeping bentgrass and POA together in a mixed stand. So here's what I was just referring to. Gibberellin, kind of a simplified gibberellin biosynthesis pathway. So there's a number of different gibberellins, and there you can see them, like for instance, here's GA20, GA4. There's all these different gibberellins, and each one of them has a different effect on the plant. If you look at this overall pathway, starting with pyruvate or acetate on the top, goes through a number of steps. This step right here is affected by those class B compounds, whereas the class A compounds would affect gibberellin biosynthesis here. So as you can see, there's just many more compounds that are affected by the class B compounds. For instance, the regulation is occurring even before this GA12 aldehyde, which is a precursor to a number of gibberellins, whereas the class A compounds, trinamycin ethyl, is much later in the pathway, so it's really only affecting a couple compounds, and in fact, it's really just kind of affecting this GA20 to GA5 conversion. Class C would be the old type 1 compounds. These are a little more phytotoxic because they're affecting the growth points. They can be used for seed head development and emergence control. They're absorbed by the foliage, so for primarily, most of the products are. There's some exceptions like imidaclor, but a little easier to get on. Some examples of these compounds would be malic hydrazide, mefluidide, and then imidaclor. Mefluidide is probably the one that is used most often, especially on golf courses that have a lot of POA annua, where they want to control seed head production. Other classes, Class D is reserved for the herbicides. Glyphosate in some situations at low rates can be used, for instance on fine fescues maybe, as a PGR. Some of these newer products are classified as PGRs in the way that they work, for instance ethofumazate or Progress. Class E would be the phytohormones. So let's say you wanted to reverse the effects of a gibberellin acid biosynthesis inhibitor and you apply gibberellin, that would be a Class E compound. But more commonly, the use of proxy would be a Class E compound, and this is ethifon. So remember we looked at ethylene. This is just a precursor to ethylene. The mechanisms aren't as well understood, but this limits top growth in leaf growth, cell elongation, much like the Class A and Class B compounds do. Also inhibits cell division. Doesn't seem to have a lot of phytotoxic effects. One thing that does happen with ethifon or proxy is kind of a lime green color of the turf after use, so it lightens the turf instead of darkens it. So oftentimes proxy and primo are applied together so that the primo can mask the effect of the proxy. So some other instances or where PGR is used, or some other issues that we may not have focused on yet. Paint lines. So athletic fields. Think about, for instance, a football field. There's a number of paint lines that are put down on the field, and as the grass grows, the painted turf then gets cut off, and you have to redo the paint line. So a lot of times, paint now is PGRs are mixed in with the paint, so that the vertical growth rate of those leaf blades is reduced, thereby lengthening the time that paint can stay on the field without being replaced. One of the issues that I didn't cover is the potential for reduced disease recovery. If you think about a diseased turf, for instance, you get a turf disease, it results in lesions on a plant or some aesthetic problem. The turf can't grow out of the disease quite as quickly because you're regulating the vertical growth, and one way that turf recovers is through growth. So that's one of the problems, is reduced disease recovery. Some of these products do suppress diseases a little bit. They have some modes of action that might be somewhat similar to some fungicides, so that's been found in a few cases. It's not a common occurrence. I already mentioned the differential response in a mixed stand, but it's particularly important when dealing with POA annua and creeping bentgrass mixed together on a golf course fairway, for instance. The product that's used to do this is paclobutrazol, which is a Class B compound. It works because the product is broken down much more quickly in bentgrass than it is in Poa annua. So essentially it remains active in Poa annua and controls Poa annua longer than it does creeping bentgrass. So if you apply it on a mixed stand, you can encourage bentgrass growth during that time when the Poa is still being controlled by the chemical. So if you're going to overseed bentgrass seed into a mixed stand of bentgrass and Poa annua, it's a good way to kind of slow down that Poa annua for competitive reasons. This is the end of the lecture on plant growth regulation.